Hello everyone. So today we can see how to conduct the compressive strength of the cubes. Okay, how to perform the compressive strength of the cubes. So you can see here this is the compressive testing display, digital display, and this is the weighing balance that you are going to see. So you can see here. So this is the standard cube 150 into 150 that we have casted. So nearly it is equal to that kgs, weight of its kgs. And after that we have to keep these standard cubes after casted 28 days. After 28 days of curing in water, we have to keep the cube inside this compressive testing machine slowly, and we have to release the knob slowly. We have to keep, okay, slowly we have to keep this, and we have to adjust the cubes in order to touch its lower and upper surface. So you can see this is the display, and after this we have to close this one. Okay, so you can see display the load that is so you can see here the load is gradually increasing. So you can see the load is increasing gradually in the compressive testing display that is in digital. You can see some cracks. So you can see here some cracks are going to be observed here while the load is increasing. So just we need to calculate the compressive load, that how much the load is going to take by the cubes, that is standard cubes in terms of kilonewton. You can see it is gradually increasing. You can see gradually increasing. So maximum load it is taking. So after reaching at maximum point of load, so it will, the application of load will stop automatically. So you can see more cracks are being observed comparing to previous one. So you can see on the right side some cracks that is on edge of the cubes, and at the center on the left side. So now you can see the again the load is increasing. So you can see here cracks clearly. So the load is increasing gradually on the cubes. So we can see now what is the load it is going to take to fail. You can see the top surface is going to be the top surface is going to be rupture. So the load is increasing again. So more load is going to take. So you can see here cracks that is going to observe. So the load is increasing gradually. So after reaching its maximum load, so the display will stop and we can note down the maximum load that is going to be taken by the cube. You can see here the top surface is clear cracks you can observe here. So the maximum load, that is 860. So this is the maximum load it has been taken. 860 is the maximum load. So this is the compressive load, maximum load that is taken by the cube. Now we have released the knob, released the load. So you can see here cracks has been observed. So now next it is the calculation part that we are going to see how to calculate the compressive strength of the standard cube that we already tested in compressive testing machine, okay, of 150 into 150 mm size. So you can see here how to calculate the compressive strength. The load that it has been taken 830 kilonewton. So now we can calculate the compressive strength of the standard cube, that is 150 mm into 150 mm. So the load that is taken by the cube, standard cube, 830 kilonewton, which is in terms of kilonewton. The ultimate load that is taken by the standard cube, 150 into 150. And after that, next we need to calculate the compressive strength, that is given by the formula load by area. Load in terms of kilonewton, area it may be in terms of mm square or meter square or centimeter square. So any one unit we should keep in terms of SI units. So the total load, that is 830. So usually for 1 kilo we have to keep in SI unit. In 1 unit, 1 kilonewton equal to 1000 newtons. So we have to convert 830 into 1000, that is in terms of newtons. So the area of the cube, so we can see here the area of the cube, length into breadth, that is 150 into 150. So it is, we can calculate here. So the area it is 150 into 150. So you can see here 150 into 150, that is in terms of mm square. So now it is in terms of newton. So for doing this calculation, so we will get around 36.88 newton per mm square. So this is the compressive strength of the standard cube after 28 days of curing, that is 36.88 newton per mm square. Thank you.